Ever wonder how your phone or a robot sees a room? Let's dive into a breakthrough that's redefining indoor navigation. Imagine a camera capturing a space, then generating 40 imaginary rays, like light beams, radiating from the lens. But instead of getting lost in complexity, the system narrows these down to 9 key rays for a quick guess. Then it refines those guesses, like double-checking your work after a first draft. Here's the core idea. SemRayLoc merges depth data distance measurements with semantic clues like identifying a door or window. Traditional systems rely solely on depth, creating a skeleton of a building but missing critical context. It's like trying to read a map without knowing which lines are streets. SemRayLoc, though, reads the meaning of each ray, transforming raw data into intelligent insights. How does it work? The system uses semantic rays, invisible lines from a camera that carry 2 types of info: how far they travel depth and what they hit, semantics like door or window. By analyzing these rays, SemRayLoc builds a probability volume, a 3D map of where you're most likely to be. Think of it as a dynamic puzzle. Each ray contributes a piece, and the system assembles them to pinpoint your location. But here's the clever part: it doesn't do this all at once. It starts with a coarse search, scanning the floor plan to narrow down potential areas, like finding the right city block on a map. Then it zooms in with fine-grained analysis, using higher resolution data to pinpoint your exact location. It's the difference between spotting a landmark from a distance and reading a street sign up close. The results? This method outperforms existing techniques by up to 3 times in accuracy. In spaces with repetitive layouts, think identical office rooms, traditional systems get confused. SemRayLoc. It uses semantic clues to resolve ambiguities, like knowing a window is on the east side of a room. But how does this translate to real-world performance? Let's break it down. Researchers tested different weight configurations, adjusting the importance of clues. For example, on a dataset with lots of furniture, S3D, they prioritized object-related clues, while on a dataset with empty spaces, Z&D, they focused on structural hints. The result? On S3D, their method was over 30% more accurate than existing tools at key thresholds. For Z&D, the improvement was smaller but still meaningful, like solving a puzzle a little faster. Here's the real twist: they taught the model to recognize room types. On S3D, it guessed rooms with 72% accuracy, though empty spaces or blurry photos tripped it up. By only trusting guesses it was 80% sure of, they cut errors and focused the search. Think of it like a GPS that only checks streets where your car is likely to be, way faster. In Z&D, accuracy dropped to 45%, but grouping similar labels, like bedroom and master bedroom, helped. It's like organizing a messy closet. Suddenly, finding your socks is easier. They also tested tiny changes in their refinement process. Adjusting parameters like alpha, how much to trust each clue, or top K, how many guesses to check, boosted accuracy by a few percentage points. It's like fine-tuning a guitar. Just a little twist makes all the difference. So why does this matter? This tech could revolutionize indoor navigation, robot mapping, or AR apps that need to understand spaces. It's a reminder that breakthroughs often come from balancing the right variables, like a chef perfecting a recipe. Here's the kicker. When they tested their method against an existing tool called Laser, their approach significantly outperformed it at 2 key thresholds: 1 meter and 1 meter with a 30-degree angle. In fact, they saw a 64% improvement in that critical metric. But Laser still had an edge at superfine precision, like 0.1 meters. Why? Maybe because it was trained on a bigger dataset. They also found that cropping panoramic images, like taking a picture of just part of a room, made things harder. Less visual info and lower resolution equals more uncertainty. But SemRayLoc's semantic-aware design still held its own, proving that context matters more than raw data. So what's the takeaway? By merging depth and semantics, SemRayLoc isn't just improving navigation, it's redefining how machines see the world. Whether it's helping a robot deliver coffee or making AR experiences smoother, this tech is paving the way for smarter, more reliable indoor navigation. Next time you're lost in a building, remember, the future of localization is all about seeing the whole picture, not just the walls.